And I'm live. That is pretty cool. Today is 26th of October 2025, Sunday. And with that, let's just begin. We will start solving questions. But before we start solving random questions, there is one question from yesterday. Uh, yep, from which we didn't solve yesterday. It is from the last contest, third question of the last contest. And let's do that. Uh, Here we go. Division 2. Yep. Let's go. 24th of October. This question. And I gave this contest virtually and only solved two questions. Standings. Let's see. Humiliate myself. Okay, friends. Rating and 6,800 rank. Yeah. Horrible. And now on to the third question from this contest. Question number C. Maximum GCD on whiteboard. The question was this: we have a bunch of numbers on the whiteboard. We have a bunch of numbers on the whiteboard, and there are two kinds of operation. In one operation, we can like remove one of these numbers, and we can only do that operation k number of times, which is here this second number. And the other operation is in which we can take any number and we can split it into three different numbers, and all of those new three numbers which sum up to the original number, each one of them individually has to be equal to 1 at least. At least has to be 1. So yeah, and that second operation we can do any number of times. So yeah, and our main goal is to perform these operations and output the final maximum GCD. Okay, GCD questions are like always crazy. Okay, we know, what do we know? Here we have 12, 12, 9, 12, 3, 3, 6, 9, right? And we can remove three numbers. If we remove this, wait, we can remove, like we have, and then we have 7. Shit, how can we make the GCD equal to 3? That is crazy. We can only remove three numbers from this. We can make this 6 and 6 plus 6 plus 2, but that is not divisible by 3. How can we even make this whole thing have a GCD of 3? We don't have to change these numbers, which already are divisible by 3. We have to change this 7, 14, 1, and 13. Yes. And we have 3. We can only remove 3 numbers, but we can, like, we can only remove 3 numbers, but we can split numbers any number of times. Yep. I came across your content recently, enjoyed your Mutex setup. Thank you for that, Tmux setup. And can you tell more about it, the whole CP Tmux setup? Okay, for uh, CP, I am just like right now I am doing CP, the project, the MIST project, and learning Rust. So I just have 3 sessions, and these 3 sessions are automatically set up by a script, which is tmux.sh, this little script. Yeah, this just sets up these 3 different sessions and creates the windows in each one of them. And I have made this thing. I have made a alias to this script. So whenever I do tmux set this command, tmux set this has been aliased to run this script. Sh the address of this script. So I can do tmux kill server and then tmux set, and you can even see which tmux set, as you can see, tmux set has been aliased to sh this thing, and there are a few commands to see this. Tmux set, I guess also, yeah, tmux set has been aliased, and I guess also which is, and tmux set, okay, tmux set which is not a command. Okay, shit, which is not a command in Mac, but it is in Linux. And then I can just run tmux set. Now the whole thing is set up. And if I do tmux ls, I see my three servers, three sessions running on the same server, CP, Mist, and Rust. Tmux attach target is CP. And in here, the other things which I use for CP are not related to tmux, but related to C++ or related to NeoVim. And there are just some remaps specifically for NeoVim. There is this one remap which is pretty crazy. This remap or this function splits the screen, the NeoVim screen, into two halves, and on the side, the new screen, this is for which is formed, compiles the code which I was typing in, and also calculates the time it took to compile the code, start time, then compile the code, then end time, then find the duration it took to compile the code, then print the duration onto the screen, and then run the code. So this is also pretty handy. And yeah, just these things. Hello, good afternoon. Yeah, these are the things, tmux and neural. And the question that we are doing is this one from the last contest, question number C. And GCD questions are difficult. And what I'm trying to figure out right now is how can we make the GCD of this thing equal to 3? Here we have four numbers, 14, 7, 4, and 13, which are not divisible by 3. And I can remove at most 3 numbers because k is 3. I can remove at most 3 numbers. So how can I remove just out of these 4, 3 numbers and make the whole thing divisible by 3? That is crazy. At most, the best I can do is remove 3 of them and split one of them to make its product, to make it divisible by 3. Like how? I can split this into 3 plus 3 plus 1, but I would still have to remove the 1. You can split this in 3 plus 3, 6, 8, but then 8 is still not divisible. 3 plus 6, 9, 5 is not divisible, and 3 plus 9, that is 12, and then we will have 2, which is also not divisible by 3. And 13, we can have 3 plus 3, the last number can be 7, which is again, shit, that makes sense. That actually makes sense. Erase. Choose an integer from the whiteboard and erase it. This operation can be performed at most k times. Choose an integer from the whiteboard. And so they are not saying when we choose an integer, it does not mean that only the first occurrence of that integer will be removed. All the occurrences of that integer will be removed. So here what we can do is take this 13, split it into 3, 3, and 7, and then remove 7. So the 7 which was produced because of this, that will be removed. This 7 will also be removed. Then we can remove this 14 and we can remove this 4. Yeah, so we only removed 3 things and now the GCD is 3. So that is pretty cool. It's pretty cool. Pretty cool. I understand you have spent time building these scripts, but would be really helpful if you can share those aliases for tmux, neovim, and cpp. Well, for the tmux, uh, for I think I have my tmux, and in neovim configuration, my neovim configuration is here on GitHub, like the whole thing. Let me check if there are some uncommitted changes. Yes, there are. What have been the differences? Rust boilerplate. Okay. cp/rust boilerplate. Shit, I messed up. ui/walrus/cp/rust boilerplate, and or I can add this whole thing. Message is added rust boilerplate set added rust boilerplate, and these two things for something I did assistant neuron. What did I do in assistant neuron? Plugins assistant neuron. I added a rust. Shit. Okay. So now the latest things are here. You can just take that here, and hello, just be him. Yeah, just be him. Added rust, the latest commit. Okay, shit. And how to solve this question? Shit, there are four numbers which we have to remove. 14, 7, 4, 1. 1 is also something that we have to remove. So we can remove 7, and the 7 which is produced by 13 after splitting it into 3 plus 3 plus 7. Those two sevens will be removed at the same time. And then we can make this 14 into 12 plus 1 plus 1, and we will be able to remove all the ones in one go. Or even before that, we can make this 4 into, no, shit, we cannot make this 4 into anything. We can make this 4 into 1. No, we don't have to do anything. We can just make this 14 into 12 plus 1 plus 1. And then we will remove all the ones. So this would be removed and this would be removed. And we already removed this and this by removing 7. And then we will, in the third operation, remove this 4. And we have only done 3 operations, and the GCD is 3. Shit, this one is tough. This question is tough. Very confusing for me. Okay, yes, cause no one can be him. Him being referring to your best version, but you can just be like him. You can pretend to be him, not be him. Hello, you did message me on Code Forces. Yo, hello. Today we will have our talking. Yes, like what Matthew McConaughey said, right? Just I'm trying to be my best version in 10 years. Yo, let's go. I guess talking about like we will be coming on VC, I guess. Today, can you also share Tmux aliases for creating sessions? I mean, they are not aliases; they are just normal Tmux commands which you can I would suggest that you can go to learn X in Y minutes and tmux. Here, there are, you can look up the commands for creating new sessions, for setting options, unbinding, binding, and where is the command for creating a new window? Well, even if the commands are not here, there is a GitHub. Yeah, these are the commands: new S, new N, and new C for creating a new session, a new window, and new this, and T for target and detach, so that you just create but do not go into the session, those things. And for the script, it is also on GitHub. GitHub has everything. Team.run. Yeah, just a single thing. Shit, this is not the Tmux script. This is my options which I have set up, but these are like no use. They are of no use to anyone else other than me because they are like configured to how I like Tmux to be. So let's go. Just be him. Also preparing for placements. Let's go. Let's prepare for placements and get money. Ah, yes. Why haven't you been giving the recent contest? I was building Mist and I wanted a break from competitive programming for a while. RTFM, yes, just RTFM. Read the friendly manual. And for Tmux, there is a Tau of Tmux. Tau of Tmux. You can read this. This is more of how Tmux works internally. And for the like commands of Tmux, you can go to GitHub, Tmux GitHub. Yeah, Tmux wiki and getting started guide. Here you have everything you need. What is a client, what is a session, Windows pane, active panes, and Tmux new for creating a new server. You can even name the session S for naming and then the session name. And you can even give commands to run in the new session. Yeah, this is cool. You can read this. No, I'm from North India. And is Jupyter book better for AIML? I guess because you can run snippets of code. So yeah, it is good. That was the question. Are you preparing for? Okay, shit, that was the question. No, I'm not preparing for placements. I'm just messing around. And as a consequence, shit, the dialogue from Three Idiots, run after excellence, success will follow. Yeah, something like that. But shit, this question is okay. I would like to skip this question for now. No, 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 no. That would be weak behavior. Okay. Now, for real, 30 minutes for this question. And this is the question. You guys can also see. Ah, damn. Same, I am from North India too. Shit. What are the chances? Right? Uh, okay, this is the question. We can erase any integer, like all the occurrences of that integer, but we can only do this k number of times. In the greatest GCD. Okay, and this is the thing. Okay, and okay, k is going to be this, and AI, AI like each value cannot be, will not be greater than n. Okay, so let's think about it. We have n numbers in total, and the smallest number is 1. The biggest number is n. So the smallest, I think binary search, the smallest GCD that we can get is 1 and the maximum GCD that we can get is n. So if we can create a function which we can, no, this is not going to work, right? Because in this range 1 to n, all of our possible GCDs lie in this range, and we cannot use binary search here because it is not like you will always, one will always be a possible GCD. So let's say green means yes, that this number is possible, and red is like no. So let's go like this. And binary search is possible when in your range the graph is monotonous. That is, either it is always increasing in some way, or it is always decreasing, or it stays put as it is. You can apply binary search in questions like this, but here we will have some numbers randomly scattered throughout this range, which are possible as GCD, and some numbers are not. So yeah, this is not a very good thing. We cannot apply binary search here. And if we like represent not the current number is not a possible GCD by, if we make a graph here, and if the current number is possible, then we will put a dot here, and if the current number is not possible, then we will put the dot here, and here the graph would look like this. So yeah, we cannot have binary search here. It does not make sense. It will not work here. And so what we can do actually is we can check all the numbers, not even this. So okay, one will always be a possible GCD, and the maximum GCD would be equal to the smallest number currently in the list. But we do have the option of removing that smallest number. So the maximum, and from all the numbers which we have, we can remove k numbers, right? Yes, we can remove k numbers. K is some number, we can remove k smallest numbers. So let's say all of our numbers, if we sort them, they like form a curve, right? And let's say these are all the numbers, number one, number two, number indexed 3, 4 till the nth number. And we have the ability to remove k numbers. And we would always like to remove, let's say, the k smallest numbers, because our GCD cannot be higher than the smallest number in the list. So we would like to remove the smallest numbers, smallest k numbers. But the thing is, let's say these were the actual numbers, and then the next number was 5. Hmm. The next biggest number was 5. So, and k was equal to 4, we removed the smallest 4 numbers. But now, yeah, it does not make sense. If given a GCD, if given a number x, can we figure out, is this a possible GCD or not? And if we can figure it out in, let's say, log n time, then we can iterate x from the smallest number to the biggest number n, and we can find the one that is the biggest. Or we don't even have to do this. We can start iterating from n and keep moving down till 1, and the first number which we find as a possible GCD would be our answer, because that would also be the biggest, and that would be the biggest number. But I think that will not work because no, I don't think that would work. Yes. Okay, what do we have? Let's say we are trying to make x as a possible GCD. Then we will see all of the numbers which are smaller than x. Okay. And the numbers which are smaller than x, we cannot, since we have two different operations, one operation is erasing the number and the second is splitting the number and thus making the number equal to a smaller number, right? And let's say we are trying to figure out if x is a possible GCD of the whole vector or not. Anaconda, shit, AIML stuff. We are trying to figure out if x is a possible GCD or not. And then we will see the let's say then S is the number of numbers, the count of numbers in our whole array A, which are smaller than x. And since we have two operations, erase and split. Split is a nice movie. Split. We have these two operations, and S is the number, is the count of numbers which are smaller than x. And we are trying to figure out if x is the GCD or not. If we can have x as a GCD or not, right? And then we have, and then we have, hmm, yes, and then we also have k. K is the number of numbers which we can remove from our list, right? So these smaller numbers, s, we cannot, we can actually split them. We can split them, and our goal, let's say the numbers which we are trying to split, uh, let's say y is a number that we are trying to split. They can be in three different forms. If we take, since we are trying to split this number into three parts, and whatever number we want to remove, let's say from our array, here can we make 14 the maximum GCD if we can remove all of these numbers? I think we should be able to remove all of these numbers. Like we can split this into 3 into 4 plus 4 plus 4, or we can split this into 1 plus 1 and 10. We can split then 10 into 2, 1 plus 1, or 3 plus 3 plus 4, and that 4 into 1 plus 1 plus 2. So basically we can convert all of these numbers by splitting them into ones and twos, and then we can say we are removing all the ones and twos, and then the maximum GCD would be 14. So, but this does not make sense. Why is the maximum GCD still 3? And that would, we would be able to make 14 the maximum GCD if and only if here in this erase operation, when we are choosing an integer and erase it, the operation can be performed at most k times. So we can like remove only one occurrence of that integer, or like all the occurrences of that integer. And if we cannot remove all the occurrences of that integer, let's look at an example. In the first test case, you may perform the following sequences. Here the final GCD is equal to 2. It is 7. So the new vector looks like this, and we would like to get rid of 9. Then split 9 into 2, 3, and 4, which does make 9. And 9 is erased from the whiteboard. Two new integers, 2 and 4, are written. Wait, the middle one is not written. Only the smallest and the biggest are written. Note that x2 is discarded and not written on the board. And this shit, the middle number is not written on the board. The middle number is not written on the board. Shit. The middle number is not written on the board. Okay. So whenever we are trying to figure out if x is a possible GCD or not, and we also have that all the numbers AI, all the numbers are in this range 1 to n. That is our range, right? And if you are trying to figure out if x is a possible GCD or not, then you take all the numbers which are smaller than x. We will have to remove all of them. And yes, we cannot remove them if the count of numbers is greater than x, and we can figure out s like pretty quickly in log n time. So that is fine. And let's see, there is a bigger number, a number which is bigger than x, a number that is bigger than x, right? Let's say some number y which is bigger than x, and we want, and this y number is not divisible by x. So what we can do is write y equal to x plus some random number, let's say z, and plus some factor of x. And this cx has to be bigger than z. And by this operation, we would be able to get rid of x or get rid of y. And we will, after doing this split, we will only have x and cx into our vector, which are both a factor of x. So this is cool. This does work. So what are the ranges which can satisfy this condition? Like how much can y be? If we know x, then how much can y vary? But if y is smaller than x, then no, we will have to remove this. So we will have to use one of our k operations. Yes, makes sense. And for all the numbers which are bigger than y, what is this? Which are bigger than x, which are for all the numbers which are bigger than x. What is the minimum number which we can split in this way, which, yeah, which we can split in this way and get rid of this non-factor part? I think so. This smaller number, because this will be smallest number, will be in our final vector. We want this to be as small as this can be and also be a factor of x. So we will make this equal to x. X is the smallest number that this can be. So yeah, y will be equal to x plus some garbage number which we want to remove, right? We want to remove, let's call it z, z for garbage. And then the last number is also going to be a factor of x. And what is the smallest value of this c that we can have? The smallest value of this c can be 2. because this c cannot be equal to 1. If this c is equal to 1, then this last number and this first number would be equal to each other, and this number which you want to remove has to be greater than x and smaller than this third number, right? This is the first number, second number, and third number, and the condition is this, or even this equal to. But if all the numbers are equal, then and this is divisible by x, then all of them are divisible by x, so we don't want to split it. Let's, yeah, sure. So this smallest value for the c can be 2. So y has to be greater than or equal to 3x. And if this condition is met, then we can always split y in a way so that we don't have to use our x, one of our k operations. So shit, this is doable. This is actually doable. Yes, this is doable. Yes, let's go. Let's go. Emacs attach TCP. Shit. Synchronize. Okay. Huh? I think, yeah, we can do this. We can do this. We got this. We got this. CPP, boilerplate, take in N and A, C in N and A. Then we will take in the whole vector integer A size N. Then for in reference X in A, C in X. And after we have filled this whole thing, then we will sort A dot begin and A dot end. After sorting A, what we will do is, let's say, in response equal 0, or it will always be equal to 1 at least. And then we will start iterating for in I equals n and I greater than 0, I plus plus plus, or shit, I minus minus, or we can just say I while I does exist. And we want to see if a circle of, should I lost the question? This one is named maximum GCD on whiteboard. And so we want to figure out if I is a possible GCD or not. So auto IT is, we have to apply binary search and lower bound in a dot begin and a dot end find I, lower bound for I. So I yes, lower bound for I, and then we'll do IT minus minus, because lower bound will give us a number that is either equal to I, or pointer to a number that is either equal, or iterator to a number which is either equal to I or small or greater than I. So we'll go IT minus minus, so that we are now pointing to a number which is smaller than I. So yeah, and now remove the number of numbers which we have to remove would be IT minus A dot begin. Yeah, IT minus A dot begin. And if rem is greater than 0, then we will see if, then we will, yes, rem is greater than 0 and rem is smaller than or equal to k. If that is the case, then k minus equal rem. Or shit, we don't want to remove, like change our main k, then instead of k we will use kk. Now k is the remaining number of numbers which we can remove. Now we will find an iterator of shit. We can here use auto lower bound, lower bound and upper bound, and here we can say equal range, which is pretty cool. And here also we can say lower. And now UB. UB is pointing to a number which is the smallest number which is greater than k, the smallest number which is greater than k. No, we don't want that. What we want is the smallest number I, 3i. Since we are using checking if I is a remainder or not, 3i. We want to find a number, the smallest number which is smaller than 3i, the greatest number which is smaller than 3i. Like how many numbers are in this range? And share, but not just how many numbers are in this range, but are not a factor of I, but are not a multiple of I. I mean, 2i is also in this range. But you cannot go linearly forward. That would be too much work. I do not use an IDE. I use Vim. Let's go. Vim. Vim is much better than anything else. Yeah. Vim is fast. K minus equals rem. So rem is something that we have to remove. We cannot not remove it. Now what we want to figure out is I is our range and 3i. In this range, from I to 3i, all the numbers that are in this range, how many are not a factor of I? And given the fact that we are not guaranteed to have all the numbers in this range, we'll have like, let's say some number from here in this range, some number from here, here, here. And right now we have kk number is the maximum number. If let's say x is the count of numbers in this range from I to 3i which are not divisible by I. And if this x is greater than kk, then we cannot have I as the maximum GCD. Okay, so how can we figure this thing out legitimately, like in a quick way? I think we can easily figure out an iterator to this thing in linear time, in binary time, in logarithmic time, right? Because our whole thing is sorted. So using binary search in log time, we can find out the position of this element. And then shit, we will have to go individually through each element in this range. But can we avoid it? If we can, that would be pretty cool. That would be fast. If we can avoid going through each element in this range. Okay, let's take a step back. Our total range is from 1 to n, and k is k, whatever it is. Then let's say we are at some random number x, which we are trying to see if that number is a GCD or not. Then the maximum number of numbers which we can have in this range, the maximum count of numbers which we can have as smaller than our x number is K. K. Yes. K. K. Yeah. K. And here when we are trying to when we went to 3 is smaller than 3, we have 1 is the only number which is smaller than 3. Yeah, that is cool. And then can we have 4 as the GCD? If we have 4 as the GCD, can we convert? Yeah. Shit. Our hypothesis that any number can be smaller, shade the smallest number which we can split and remove some number from. It is like 3i, that is wrong. That is completely wrong, because when we are splitting the number, we have the first number, second number, and the third number, and the property has to be like this. And since we are trying to make the first number and the last number a factor or a multiple of x, then the smallest number, which can be the first number, is x. And since all the numbers to the right are going to be greater than this number, so both of them have to be at least x. The next smallest multiple of x after x is going to be 2x. So this number will be minimum x and at maximum 2x. If this number, if so the whole thing would be, since we have a x here, and 2x here, and 4x. If this number y, let's say, which we want to split, and it is not a multiple of x, we want to split it and remove some part of it so that the remaining parts are divisible by x. Yeah, so that the remaining part are divisible by x. Then if this middle number, if this y is greater than equal to 4x, then we can, I think we can always split this y in such a way that the remaining numbers are divisible by x, and that is what we want, 4x, because let's say we are making the smallest number x unconditionally, and we make the biggest number equal to 2x. Then then the middle number can range from x to 2x, right? Yeah, cool. Let's say the number is, this number is, and okay, so here when the middle number is equal to x, then the whole sum is 4x. Then the whole y number is 4x. When the middle number is equal to 2x, which is the maximum value it can have, then the whole number is y is equal to 5x, right? And let's say y is greater than 5x. Let's say it is like 5.5x, right? In this case, we will keep our smallest number equal to x, then our biggest number, since we have already used 1x, we will make this number equal to 1.5x, let's say. And yeah, we have already used 2.5 out of this 5.5. We have 3x remaining, which we can make the last number equal to. Okay, shit. So if we are checking if x is the GCD, then all the numbers which are greater than or equal to 4x, then we can always split them in such a way that the final remaining numbers, which will be the first number and the last number and the middle number, will be removed. The final remaining numbers will be a multiple of x. So that is cool. And yeah, that is cool. And the numbers which we will have to remove, yeah, the numbers which we will have to remove are, first of all, when we want x to be the GCD, are all the numbers which are the count of the numbers which are smaller than x, and the count of the numbers which are greater than x but smaller than 4x, and also are not multiples of x. And shit, the only numbers which are multiples of x in this range are going to be 2x, 3x. So shit, we can easily figure out this count. Yeah, we can find out the address index of this number, right? That is good. We can easily find out the index of this number. We can easily find out the index of this number using binary search, and we will see if 2x and 3x exist in our vector or not. And if they do, then we will remove 1 and 1. And we can always count the numbers in this range. And if there is the number of times that we see 2x, we will remove that number from this count. This is all small. This is LG large. And the number of LXD large. The number of times that 2x and 3x are appearing, we will subtract that from LG, and we will call that number F. So if this whole number CMX plus CLG minus F, if this number is smaller than or equal to K, then we can have X as a possible factor, and we can figure this thing out in log time. Cool, we got this. New hello, hi. Shit, bro has been hiding for a long time now. How you started your journey? Can you explain for where you learned everything? I don't know anything. Let me show you. Daniel, not Day Lewis. Daniel Naroditsky. Shit. Daniel Steinberg. Shit, that is not the guy I was looking for. Curl GitHub. Where is Mr. Daniel? Yeah. Daniel Steinberg. Yeah. I don't know anything. Yeah. But I'm not on Team Curl, but I don't know anything. Yeah. That is the stance. And hello, come to VC today. We will have a nice talk. You can flex. You will have to give ASMR with your Kinesis keyboard. That is one condition for entering in the VC. So shit. Okay, this is our function. F will take x and give us true or false in logarithmic time. Yeah, cool. For int I equals 0, I less than k less than equal to k and I plus plus. So I is the uh, AI is the number which we can remove. Okay, and we know when we are at AI, we will have to remove all numbers which are smaller than this. But 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 not always. Okay, what we will do is while I smaller than equal to k and AI plus 1, I smaller than k, and the next number AI plus 1 equals AI. We will keep increasing I. Okay, and why this? Because let's say our vector could be like this, right? And when our I is here, then it is okay. We just have to remove 1. But when our I is here, we will consider that we will have to remove all the numbers which are smaller than this. But this 3 is already divisible by 3, this 3. So we don't want to remove this. So what I'm doing here is messed up. Shit. Okay. Sm equals I. I is the number of numbers which we have to remove. So when, let's say, now we come here, then and I is equal to 1, which is true. There is only one number to the left which is smaller than I, and we have taken it as Sm smaller than the current number. And while the next number exists and the next number is equal to the current number, we will keep increasing I. So while I is smaller than k and the next number is equal to the current number, we will increase I, so that if there is a continuous sequence in which all the numbers are equal to each other, then when we come out of this loop, we will be pointing to the last number in this continuous sequence, which is just same. So that is nice. Like how you started from which language? Let's say yeah, C from CS50. Yeah, this thing is pretty cool. And loading up. Save your skills on that matter. Get up to 15% off it. This thing, and this was pretty cool. And now on to this. So now I is at a nice place. What we need to figure out, since we already have this number Cm, which is Sm here, we need to figure out the count of numbers which are in the range ai greater than ai and smaller than 4 ai. Yeah, which we can say auto upper bound, lower bound, lower bound, upper bound equals equal range in a dot begin and a dot end, and shit, this number, like the biggest number that is smaller than ai, we will have to find upper bound for that. Shit. A upper bound equals, we cannot use equal range here, a dot begin and e dot end, and we are looking for ai, the upper bound. Auto lower bound equals lower bound a dot begin and a dot end, and the number that we are looking for is 4 into ai. And since this lower bound is equal to a number that is either equal to 4ai or greater than it, and in both the cases we will have to go back to the number, to the previous number, previous previous number, so that we are pointing here at a number which is smaller than ai. So now down count, or we had sm there, let's call this bg, like the numbers which are bigger than x, then ai, and are in this range from ai to 4ai. That would be upper bound, lower bound minus upper bound, right? And if this is greater than 0, and here we'll say, yeah, we must remove sm numbers. That is nice. If pg is greater than this, then now what we have to do is, in this range there can be only 2 ai and 3 ai, which are factors of ai, and every other number we will have to use one of our erase operations to erase and get rid of. But on both of these numbers we don't have to do that because these are already divisible by ai. So we have to find out the number of times that this number is occurring and the number of times that this number is occurring, which is easy to find out. We can say auto upper bound and lower bound and upper bound equals, now we can use equal range on E dot in and E dot n, and let's say first of all for 2ai, and the number of times that 2ai is occurring would be, let's say, bg minus equals upper bound. Let's say we did this equal range function, let's say for some number x in something, and let's say x is occurring a number of times, then lower bound would be pointing to this number, this first occurrence right here, and upper bound would be pointing to this number which is greater than x, uh, which is greater than x, some number. So if we do this upper bound minus lower bound, we will get the number of times that x is occurring in our list. So that is what we will do, upper bound minus lower bound. And we just subtract that from bg, because bg is the total number of numbers which we want to remove, and don't want to remove the number of times that 2ai is occurring. We will do the same thing for 3ai, lower bound and upper bound equals equal range a dot begin, a dot end, and something happened to my typing speed. Mm, and bg minus equals upper bound 3 minus lower bound 3. Now, the total number of numbers that we must remove for ai to be a GCD would be, if or shit, we don't have to do this. We can say this begins from, no, this is fine. This is fine. So this is okay. Yeah. If k is the maximum number that we can remove, if k is smaller than equal to bg plus sm, then we can have this ai number as a answer. So we will say rest equals ai, and at the end see out ai, not ai, and hopefully this thing works. Shit, okay, the loop is not ending, or okay, shit, we totally messed up, it seems. Okay, something wrong. Just brute force, right? You can use prefix array for frequencies. Prefix array for frequencies, no need to use upper bound and lower bound. And what does the equal range function do? And in the loop, start from n, go towards 0, and you can just break whenever you find a number. Okay, yeah, brute force from the right end. Okay, that makes sense. And the lower bound, the equal range function gives us both the values, lower bound and upper bound. So that is pretty nice. No need to use upper bound and lower bound. Equal range function gives us lower bound and upper bound. And in the loop, we start from n and go towards 0. That does make sense. And then we can break and -1, because whatever the first number, I will just have to change the loop logic a little bit. Greater than equal to 0. Not a little bit. Shit, SM, and we can use prefix, you said. Okay, I'll use prefix after I make this thing work. Now, since we are at the max, at the rightmost element that this is occurring, first we will have to find out these two things. BG. Yeah, so we won't be doing these two steps. First, we will do find the upper bound and the lower bound for this number, and lower bound minus minus upper bound. Okay, E dot begin and E dot end after sorting AI. Okay, we have the upper bound and the lower bound BG. Okay, BG is greater than 0. Put this here and bring down this. As BG equals 0. And okay, then all the times that AI, 2AI is there, and all the times that 3AI is there. We don't want to, or we don't have to remove those things. So that is nice. And then SM, before calculating SM, what we will do is YI and AI minus 1 equals AI I minus minus I minus minus. Then I is pointing to the last or to the first occurrence of this number, and we will have to remove all the numbers which are to the left, which is just I. And also this has to be minus minus. Now, if k is smaller than or equal to the numbers which we have to remove, which are I plus bg. If that is the case, if that is the case, then bingo, yes, it's go. Then answer would be equal to AI and then okay, shit. In this thing, this is 14. We can have 14, but we cannot have 14 as the correct answer. BG would be small, like BG is here, lower bound for this, and upper bound for this. Okay, and if BG is greater than 0, BG would be 0 in case of 14. I'm very stupid. Okay, that is still wrong, but I said 2 here instead. The answer is not 2 in the second one also. Here, k is equal to 1. Okay, and k is equal to 1. 9. Can we convert 9 into a number which is both the numbers are divisible? Shit, that makes so much sense. We have 7 and 7. Right, we have 7 and 7. 2 is the smallest number, so the big numbers which are bigger than 2, which we must split, are 7 and 7. Shit, yes, 7 and 7, but k is not equal to that. Messed up big time. Yes. How much is the indentation? Tab 8, 8 spaces, and no tab. Uh, 2, right? Shit, why would this not work? When we have 2, 6, 6, 7, 7, and then 9, or let's say even 8. In this, if we do upper bound for AI, which is AI is 2, upper bound, here we will get 6, which is like pretty cool, amazing. Yeah, we will get 6. Okay. And when we do lower bound on 4AI, 4AI is 8. We will get 8 plus 1. Check. Because upper bound is pointing to this number and lower bound is pointing to this number. So we have to do plus 1 because both of them are inclusive. Let's go. Let's go. And this does work. Shit. Shit. Okay. This does work. This does work. And yes, after this, I will like to apply your solution using prefix array for frequencies. Okay. Messed up big time. Bro, never stop streaming this is CF live problem solving regardless of how far you go. Okay. Krishna, the only truth. God himself. Yes, no tab. And no cap. No cap. I use spaces. And okay, so something is wrong. Let's rewrite the whole thing. We have n and we have k, n and a, n and k. Let's fill our vector in a power n and for shit in reference x in a take into x. Now this is filled. Sort a dot begin and a dot end. Sort this whole thing int response is equal to 1. And what is our range? Yeah, the smallest number that we can have is 1. So choosing response equal to 1 is not a very bad thing. It is like, I'm still very smart. And then int I equals n minus 1, I greater than equal to 0. We'll go till the last element and I minus minus. Now, we want to see if AI could be our GCD, right? And AI is the first, is the rightmost occurrence of this AI number because we are going from right to left. So I is the rightmost occurrence of this number. So now we will apply our lower bound and upper bound functions. Bound, upper bound, a dot between and a dot n ai. So ub is pointing to the smallest number which is bigger than ai. Let's go. And then lower bound, a dot between and a dot n 4 into ai. Okay, now lower bound is pointing to the to ai to 4ai or a number that is greater than 4ai. And in any case, we would like to find the smallest number, the greatest number, which is bigger, which is smaller than 4ai. I have to work on me articulation, lower bound minus minus. And now BG is the number of numbers which are bigger than AI and we have to remove. That would be lower bound minus upper bound plus 1. And is this okay? This is okay. Now, if BG is greater than 0, if it is a positive number, then in this BG range, we have to remove the occurrences of 2AI and 3AI. So, auto, lower bound, upper bound equals equal range n a dot begin and a dot n, and we are looking, let's say, for first of all for 2ai and auto lower bound 3, upper bound b equal range a dot begin and a dot n 3 into ai, and lower bound returns the forward iterator last then the value. And yes, this is the thing that this function returns pair of forward iterator and forward iterator, but which one is the lower bound and which one is the upper bound? I would suppose that the first number is the lower bound and the second number is the upper bound. Equal range, CPP reference, let's go. It is, yeah, lower bound is the first number, upper bound is the second number. Okay, so we are good. BG minus equals, yeah, we can just do upper bound 3 minus lower bound 3 plus upper bound minus lower bound. That is very nice. And otherwise b equals 0. Yes, now we have successfully figured out all the numbers which are bigger than AI, which we must remove using our given key number of operations. I guess you are getting a wrong answer because AI might not always be bounded by n. Okay, that makes sense. And if they are not bounded by n, then if they are not bounded by n, then upper bound would point to a dot n and lower bound would also point to e dot n and e dot end, right? And lower bound, when we do LB minus minus, lower bound, this function, this iterator would be pointing to a number that is to the left of this number. So when we do this, we will get 0. And so our answer is not like jeopardized because of that. Because here we are checking if BG is a positive number. And BG would only be a positive number if there are numbers in that particular range. Yeah, that makes sense. And now we have to figure out all the numbers which are smaller. Yes, yep. And only subtract if they are lesser than n. And also AI could be greater than n. That is fine. That is fine. It is taken care of. And now while I is positive and AI minus 1 is equals AI I minus 1 minus 1. Now if k is greater than equal I plus bg, then rest equals AI and take C out rest LSP stop. I don't like this LSP. The name of the question, the name is prime is it max. So GCD on a whiteboard. Yes, LSP is off. This is pretty nice. We're getting the right answer here. And n is also like just at maximum 10 power 5. So that is nice. So that is nice. When we are doing 2 into AI or 3 into AI, we will not get very big numbers. This should work. Uh, let's see. Shit. I think we can look at the wrong solution or the thing which is messing up. On the 611th answer, expected 2, found 1. So we are giving out a smaller number. Shit. Shit. Okay. Makes sense. Shit. 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 Instead of using I as the index, we should use I as the number which you want to find as like, oh shit. Makes so much sense. So right now we were looking as if we want AI to be the GCD, but actually we should look at I to be the GCD. Maybe the GCD that we want is not there yet, and maybe we can make it happen. For example, yeah, for example, let's say we have 3, 8, and 10. We have 3, 8, and 10. No, no, no. We have 3, 8, and 11. Yes, and k equals 0. We cannot remove anything. In this case, the solution that we have written, this will give that 1 is the best GCD possible, but actually we could have 2 as a GCD. We can split this one into uh, 2 and 3, 2, 3, 5 minus this 6, 2, 3, 6, and we will remove 3 from this, and we will have 2 and 6 instead of 11, and so the total final array would look like this: 10 and 11, and here 2 is the correct answer. So that makes sense. You did say that we should go from n to 1, but instead of looking if I is the GCD, I looked at if AI is the GCD or not. That makes sense. Okay, so we will have to change our code a bit. Instead of AI, there we can actually do. So here we have to change AI with I, makes sense. And here also we have to change AI with I, makes sense. And yeah, for lower one we can manage. So we can use substitute AI, like literal this thing with I. Yeah, why is this not working? A this I ending bracket, put I there. So BG is now okay, and we don't have to do this. You don't have to do this. We want to find out how many numbers are smaller Then I, how many numbers are smaller than I, for which we will do this equals lower bound. And yes, you were right. Using prefix would be a much better way of doing this. And after this, we will use prefix because we don't have to do n log n things every time whenever we are calling these four functions, right? Lower bound, upper bound, equal range, lower bound, yeah, lower bound for in AI dot begin and A dot end, and we are looking for I, like give us I, and then we will do IT minus minus, and in SM, the numbers which are smaller than I would be literally IT minus A dot begin, or maximum of A dot begin, or 0. So, and here instead of adding I, we will add SM. And hopefully this thing fails. Shit. IT, this thing, what does this return? Let's make it our integer. Void invalid cast. This thing will, okay, IT minus A dot begin and SM equals SM, uh, maximum of SM comma 0. Okay, out of bounds does not make sense. Where are we going out of bounds? Here we are going out of bounds. Wrong answer is messed up. Wrong answer is messed up. Here in the third last, we are saying we can have 5 as the answer, but third last, this one, 4, which is, yeah, yes, completely plus 1. Okay, shit. This thing has to be this plus 1 because IT, shit, we don't even have to do this. We can now avoid the plus 1 because right now IT is pointing, we don't even have to do this here. Here, IT is pointing to the first occurrence of I in the vector, or to a number that is bigger than I. And when we subtract from that the first number, then we will get all the count of the numbers which are smaller than I. That makes sense, and this should work. This does work. And let's submit, and we will see how it goes. Let's see. His solution for this question also very nice. Well, C++, I love C++ language. Let's go. We have common love interest, I guess. I'm a new viewer. Hello. Who is Mr. History? Who is Mr. History? Heinrich Himmler, Adolf Eichmann, I don't know. Or shit, hardcore history. Who is the person in hardcore history? Dan Carlin. Dan Carlin. He's like one of the best human beings, one of the best historians, I would say, right now. I've tried Zig. Nope, not yet. And 16. That is like 4 square. Accepted. Cool. Let's go. And whose solution do you mean is better? Is like also good. It's a good language. Yes, it is, well, very complex. I would rather write production code in some other language, but C++ is good in the sense that it is very difficult and the barrier to entry is very high. And if you are good at C++, then you understand how the computer works. So that is pretty cool. If you are good at C++, then you are generally a good programmer. But if you are good at a language like Python, then it is very hard to switch to C++. But if you are good at C++, first of all, you know how computers work internally. And second, it would be easy for you to switch to any other language. And by switch, I don't mean forget the previous language, just increase your scope. Increasing scope is easier. And let's now also use the prefix sum. Shit, I know, I have seen this guy. He's like pretty cool. 2200 rating. He is like, yeah, he's much better than me. He's pretty cool. And he streams while the contest is going on, which is crazy. I think he does stream while the contest is going on, which is crazy, literally. And now this thing. Let's write it with the prefix method for which we'll define if I to be the count of numbers which are smaller than which are count of numbers in range 0 to I, where 0 and I both are included. And cool. Vector in A size n for in reference x in A, C in x, and A is now filled up. We will sort this. How do we fix write this prefix? Okay, sort A dot begin, A dot end, and vector we will also have our prefix size n for n I equals 0, I less than n equal to n less than n I plus plus equal to n, and here n plus 1 would be the size, and I would start from 1. So how many times? Okay, how many times is a 1 occurring in A? That would be in, let's say, x equals I, and while x is smaller, yeah, while x is smaller, x is equal to this, while x is smaller than n, right? And the next number, a x plus 1 equals ai into x plus plus, not ei. This number, while this number equals, shit, no, n plus 1, we can use the math. Yeah, just a map, and for n I equals 0, I less than n, small n, I plus plus, take into C, where C is this number, and NP C plus plus, and here prefix I equals prefix I minus 1 plus the number of times that this I is occurring. Cool. And now we can start. Rest equals 1 for and I equals n and I, while I and I minus minus. So for the numbers which are bigger, for the numbers which are bigger than AI. Okay. And we must remove. We'll also have to do some bound checking here because 4 into AI could be very big. Ah, oh, yes. People will copyright. How to learn new Vim? Are you in college? Yep, I am in college. And to learn new Vim, you can look up new Vim, the prime engine. If you want to understand like how to use new Vim, then you can watch this series, Vim as your editor, full thing. This is pretty nice. You can watch this. And if you want to understand how new Vim works, then I would say VHYRO, Vyro, and Vim. You can watch this series, Understanding New Vim. This is pretty cool. Like one of the best out there on seeing how new Vim works. Yeah, you can watch these two things. And okay, when we are at a particular I, getting the numbers, count of numbers which are smaller, is easy. Yeah, it is easy. You can just say int sm is prefix I minus 1. But the count of numbers which are bigger int bg initially equals 0, and if 4 into I is smaller than or equal to n, then this number, then all of the numbers are in the range. Like by all, I mean, yeah, we don't care about the numbers which are bigger than AI4, I into 4. And yes, do we also have to look n equal to? Yeah, even if it is, if n is equal to, then this thing works. Uh, Now, this is okay, right? Right. And VG would be equal to number count of numbers which are smaller than 4 into AI. That would be 4 into I minus 1, right? And minus the count of numbers which are bigger than I, which would be I plus 1. I, prefix I, yes, I. Now we have this nice little range and we have to remove from this the number of times that 2i is occurring and 3i is occurring. So bg minus mp 2 into I plus mp 3 into I. And we know that these two things exist because, yeah, 4ai is in the range, right? Else, if else we know that this is not the case, in which case you will count the total number. Wait, we'll just do else. Else bg equals n is the total count of numbers minus prefix I, all the numbers which are small. And bg, so we can remove this. And this is a common statement. And now if k is greater than or equal to bg plus BB plus SM. Then the response is I and B. 'A' dot begin and 'A' dot end. E does not exist, which is a true statement. It does work. This does work using the prefix method. Let's see. This should work. This should work. Shit. Messages have been retracting, and 21 is a nice number, 3 into 7. And isn't this pointless? What do you mean? Better to learn something that can help others. This stuff is useless, then you don't have to watch. No one pays you to do coding problems. Okay, I'm not doing this because anyone is paying me. And this and industry code is different. Okay, I didn't say I'm writing industry level code, and I did all this before it was waste of time. Okay, thank you for your advice, but I will still continue doing these questions. Bro doesn't have the energy. Shit. Okay, shit, this doesn't work. This doesn't work. Yeah. And yes, you said, what is the point? I mean, okay, if there is no point, that you don't have to watch. I have my own reasons. Even if I don't have my reasons, I'm not forcing you to watch or do any questions. Okay, prefix I is an count of integers in this range. Cn, if C is there, increase the count. Okay, prefix I, uh, yes, the count of integers in the last, and also the count of the current number I. Okay, this is also good. Prefix size is also n plus 1, which is pretty nice. And here we have res initially equal to 1, which is also nice. And then I equals n, and while I is a positive number, we'll do I minus minus, and then Sm, smaller numbers would be the count of numbers which are smaller than AI, which is this. Yeah. The count of numbers which are smaller than I, which is prefix I minus 1. Yes, nice, because we will have to remove all of them. And then BG is bigger numbers. And if 4 into I is in the given range, then BG would be, uh, huh, this, but if not, then last, then the total count minus prefix I, which is also true. And these two things, MP 2 into I and 3 into I, would return 0 if they don't exist, and would return the corresponding values if they do exist. So that is nice. Is smaller than n. The maximum index that we can index in this thing is n. So, so if this minus 1 is equal to n, right, that makes sense. Shit. MPC plus accepted here and here. Copy paste, and let's see. You didn't get out money. Papa is taking. You don't know. You don't know that, right? I wanted to help you as a good friend, but anyways, have fun. Thank you, and you too have fun. I work in Google AI engineering. I saw your stream, so hello. Yeah, that is nice. You are working in Google, and you do know about this. And by learning AI, my only recommendation. Yes, I will learn AI next year, like 2026, when I'm good. Right now, I'm learning, getting better at CP and a few other things like Rust and a little network programming project going on the side. So that is nice. And yep, so that is done. We did this question with using the retard method that I came up with binary search, lower bounds and upper bounds, and also with the recommended method, which was recommended in the chat using prefix. So that is nice. That is nice. We can use prefix. Okay, shit. So what is the thing that we learned from this question? That would be that would be the things that we have learned from this question would be, well, one of the obvious things would be we can use prefix to find, I mean, just the way that we define prefix here, that prefix I equals count of numbers in range 0 to AI. So I think this was a novelty. I've not done this kind of prefix definition before. So that is a new thing. And what else? Well, yeah, the other thing would be we should brute force if we can afford it. Yeah, that would be the other new thing. But this thing also we knew from before. We have done questions which apply this concept of brute forcing, and this is also called complete search when we do brute force things. That would be it for this question. And now we will do some random 1500 rated questions and hopefully faster than 1 hour. Problem set 1500. Let's go. Bro, still solving this. Damn. Well, we did it. It now works. We did the question. It now works. And now some mix cycle. Let's do this one. Mix cycle, 3 strings. Bewitching stargazer and trip to the Olympiad, graph composition. So that is some Russian thing. Devyat, vlog. That is definitely Russian vlog. And this is the next question. But before we do this, I will have to go to the washroom and I will be right back in just a minute. And Me simply eat 5 stars, do nothing. Simply eat 5 star, do nothing. Shit. 5 star, that is nice. Yes, we can just eat 5 star as the world keeps in. Like this one. Okay, what is this? Whatever this dragon has many friends. They have 3 friends. That is one more than the average dragon. You are given integers n, x, and y. There are n dragons sitting in a circle. The dragons are numbered 1 to n in total. I, for each I, dragon I is friends with the ones which are his neighbors, where dragon 0 is defined to be dragon n and n plus 1. Is okay, dragon 0 is dragon n and dragon n plus 1 is 1. Additionally, dragon x and y are friends with each other. If they are already friends, this changes nothing. Note that all the friendships are mutual. Output n non-negative integers ai to an such that for each dragon, the following holds. Let this be the friends of dragon I, then ai would be the max of all of these dragons friends. Shit. Okay, shit. There might be too much layering. Shit. We are defining AI in terms of AI. Okay, we do know what max is, but isn't this like circular definition? Here we are saying AI is equal to AI. Shit. Okay. For a certain dragon, this is all the friends that this person has. All the indices of the dragons, which I dragon is a friend of, and then AI equals mix of all of his friends' values. Shit. We okay, so it seems like there can be solution. Okay, so that is a definition, circular definition. That is definitely circular definition. Okay, so dragons are sitting here. 1, 2, 3, 4, 5, dash, dash, dash. And let's forget about this condition, x and y, that these dragons are randomly friends. Do beautiful sequence. Okay, we'll do this out. Do beautiful sequence after this. They define a wrapping ring with an off by one asymmetry. Beautiful sequence. Okay, after this, and super hard to read. Mess. This is messed up. Yes, this is circular definition. They defined a wrapping ring with an of offset by one asymmetry. Offset by one. I have used Express, right? Yes, I have used Express JS. Okay, let's forget about the X and Y conditions. Off by one symmetry. Off by one symmetry. Off by one asymmetry. That is something that I have heard for the first time. And also this thing, a wrapping ring. I have not heard a wrapping. I think I have not heard a wrapping ring before. And also off by one asymmetry. Something new. That is nice. And okay, should okay, cool. Let's say not let's say these two are friends. So for we can begin anywhere, does not matter. Let's say we only have four dragons. Let's go with four. One, two, three, and four. We have four dragons. And let's fill this vector A. So this dragon number one is friends with this and this. So to fill this thing, we need to know the values of this and this. And to fill this thing, we need to know the value of this and this. I think we can wrap around AI, and instead of these, we can make a circle of AI and write A1, A2, A3, and A4, where uh, this is a friend of this and this. So AI is the mix of this and this. And same goes for everyone. AI is equal to mix of A4 and A2. Let's, I think we can just take there might be multiple possible solutions. So we can suppose AI to be equal to 0. So since we are saying AI is 0, so A3 and A4 will not be 0. Let's say 1 and 2. So 3 is mix of this and this. But also we have this has to be mix of this and this. So 3 cannot be equal to 1. 3 has to be greater than 1. 3 can be 0. Shit, if 3 is 0, then this thing would be 1. Makes sense. Shit, are they just 0 and 1, 0 and 0 and 0 and all the way around? Because this thing definitely holds. Can we even have, let's say, 2 ever? Like, can AI for any AI ever be equal to 2? I don't think so. For example, uh, for example, in our circle, we have some AI which is like equal to 2. So for this to be equal to 2, at one place you would have to have a 0, and on the other side you would have to have a 1. And for this one to exist, we need the other number to be equal to 0. Then we can have a 1 here. Okay, so that is also nice. For each test case, n and 1. So yeah, I think we can just, here we had n, n was even, and we began with 0 and the last number was 1. If n was odd, like 5, so a1, a2, a3, a4, and a5, and we began with a0 equal to 0. We'll say 1 here, 0 here, 1 here. We cannot have 0 here. We will have here 2, which is nice. Okay. So if n is odd, then we will keep alternating and the last number would be equal to 2. And if n is even, then we will start from 0 and the last number would be 1, and we will keep alternating. And now let's introduce this new condition. X and Y. X and Y are two random people which are just friends with each other. No, yes, sorry, it is not off by 1. I was confused by the index. Shit, okay, you meant the index is one index. Hello, let's go. And this is programming. We are trying to solve this question. Suppose I have made a React project, but I don't know how to use Express in my project. Can you explain it to me? Express is just used to make API points, which you can call from your front end in React. And yeah, that is it. Express is just used to make like endpoints. You are backend, the server. Express is used to make servers, and you can make endpoints, which you can call from your React front end to get data or put something or anything. Does not matter, whatever. So yeah, Express is just a backend library in for uh, JavaScript. And Express.js, you can just look up how to write stuff in Express.js like this. Require Express. Then on this port, when someone searches for like the root of this port, your IP address at this port, at the root folder, they will be given this response. That is what Express is. It is not for API calls, it is for the backend which will handle the API calls. You will call the API from your React frontend, and Express will take in the request and process whatever was asked and give your React frontend the data which is required by the frontend to display. Like here on this website, I mean the backend frontend model, like the basic backend frontend model. Here, when I search https expressjs.com, then my browser sends a request on a IP address, and that IP address is this react.com. Where does the first request goes? Shit, why is this? The first request goes to this address at port number 80. This was a get request, and this generally on some shit. The server was Cloudflare. The server was Cloudflare, and the server might have been written in Apache or something. This was all the data that was sent by the backend and which was rendered by our browser here. Yeah, just basic front end and back end model where the front end is in React and the back end is in Express. Same thing. Okay, now the condition where we are saying two random people, X and Y, are friends with each other, which would just mean okay, so we will first of all make this thing and then we'll see the values of AX and AY. If AX and AY are not equal to each other, then the answer would not change. Let's say we make this person and this person a friend, the answer will not change. Yeah, answer will not change. Why? Because we know for a fact that since AI or whatever AX is whatever it is, because the mix of all the numbers, which is just like two numbers we have taken, they are all smaller than AX. And when we have AY, it, and we are saying AY is not equal to AX. AY is not equal to AX. Then shit. We have AY not equal to AX. So AY is either smaller than AX, which would not change the mix, or AY is greater than AX, which would also not change the mix. So if these two numbers are not equal to each other, then that has no bearing at our final answer. But if they are equal to each other, well, since we only have 1, 2 in our whole answer, so yeah, we don't have to think about if the numbers are even or odd. That is already taken care of. Let's say we have this as our AX and this as our AY. Both numbers are 1. Okay, 1. Both numbers are 1. So we have to take 1 and increase its value by 1, right? So which one can we take? We cannot, we can change this number's value because this number is only affecting the mix of this and this. And since this number is already like greater than this number, then we are cool. But we cannot change this number because this is 1. That is why this thing has to be 2, right? Yeah, that is why. So if the number that is, first of all, if AX is not equal to AY, then everything is true. But if AX equals AY, and there can be now only two conditions, that both are equal to 0 or both are equal to 1. And when both are equal to 1, then, and also if this thing is even or odd, when we have even like even number of numbers, let's say 0, 1, 0, and 1 even, then every number has two neighbors. So shit, if I were to increase this number by 1, let's say this and this. Yeah, if I were to make this number a 1, then this thing, making this number a 1, does not affect this number and also this number because they already have a 0 here. So that is nice. And what is the minimum value of n? N can get minimum this. So even if, so okay, we will only make a change when AX equals AY. And also we will look at n, if n is even or odd. If n is even, then we can just increase either AX or AY, does not matter. But if n is odd, then we have to see, then we will increase the value of whichever number is lower, like if X is lower or Y is lower. No. If X is equal to this or this. Shit. No, this is fine. This is fine. This is fine. Yeah, if one of these numbers, X and Y, is equal to like the first number or this number, then we won't change them. We will change the other number. And there should not be any other variant, any other like problem. Yeah, cool. We got this. Cool. So this, so is it to just provide the static or maybe dynamic files to browser? Okay, it is providing your browser with files. And I don't get what you mean by static and dynamic here. Static in reference to a website only means a static website. So, okay, there could be two definitions of static and dynamic website. One definition is if your website does not have JavaScript, then your website is static. And if it has JavaScript, some moving elements, then it is dynamic. But there is also another definition which says if your website does not have a backend, then it is static website because everything that is required to run your front end is already there. For example, the website which don't require any data, extra new data, and where you don't have to log in. Those would be the websites which are static. For example, this website could be or could not be. Shit, I don't know if this is, but yeah. So there are two definitions for static and dynamic. Hello, you have been here before. It's for routing. Yes. Like my project uses logo or some data in some files. So those files are only available in localhost, so we can provide it to the browser or other user can access if like the code for your front end. If your code itself has the files, then you can ship your front end with the files which are required. If those files are like not changing, if those files are static, if you already know which things you want to display, then you can make those files a part of your front end which you are going to ship to wherever you want to run it. Then yeah, then it would be okay. So just make those files a part of the front end and they will be shipped with the front end. You don't need a backend. React router is for routing on the front end. So, okay, there are like two types of routing, routing on the front end and routing. React is everything related to the front end. Charles Bukowski's Tombstone. Yes, that is so good. It is good. Don't try. React router is routing on the front end. Request get success when we didn't use Express in localhost. So, okay, when you go to a website, let's say google.com, I will just explain. Let me get this one first. And I think I know how to do this question. Rega, I can stop the stopwatch. Okay. So when you go to a website like google.com, then this thing, this URL turns into a IP address. Your browser has ways of figuring out which IP address this thing belongs to. Then your browser sends a request to your router, your Wi-Fi, asking for like sends a request at, let's say, when you write HTTPS, which is important, HTTPS :// google.com. This thing, your browser has ways called like DNS, which it uses to figure out which IP address this thing belongs to. So let's say the IP address turns out to be some number like this, right? This is like not even in the right format. Let's suppose that this is the thing, right? And looking at this first part, HTTPS, your browser, well, first of all, to send a request at anything, you need IP of the target computer and the port of the target computer. Your browser already knows the IP address through a thing called DNS, name domain name service, which are servers which your browser uses to figure out IP addresses for websites from URLs. Then looking at this first one, HTTPS, your browser knows that HTTPS runs at port 443. And if you had like HTTP, then your browser also knows that for HTTP, the port number is 80. So now your browser knows the IP address and the port number, right? So IP and the port is also known. Let's say it is 443. So a request is sent out to this IP address, and that IP address sends back HTML, CSS, and JavaScript files. Just three things: HTML, CSS, and JavaScript, right? And okay, so you sent your request to this thing, to this IP address. Then this thing sent back three things: HTML, CSS, and JavaScript. And what are the things like, HTML is for the structure of the thing, CSS is for styling, and JavaScript is for like uh for interactivity, for dynamic things. And what was this server? This server was something. This server was something. This server, this IP address at which you sent your browser sent this a request. And okay, let's suppose yes, there was a server which was running at this IP address, at this port, which sent you these three things: HTML, CSS, and JavaScript. Now, the JavaScript, when I do this thing and I see a bunch of things here, these things are like the JavaScript which was sent to me is written in such a way that when I do this thing, or what happens when I click on this thing and my cursor is here, then this front end does not know which files to display. So the JavaScript which is running on your browser now, the JavaScript is the one that sends new requests to some server, to some server, and that server could be the same as this server which was running earlier, or some other server, any server, and they this the mode of communication between this JavaScript which was originally sent to you and this new server, this is defined by these two things. Like, now your browser has nothing to do. Your browser just takes requests which this JavaScript wants to send, and sends the request to the server, and the server responds back. And yeah, so that is how this JavaScript figures out this is what the data this website, this JavaScript is asking for from the server. And your question about, so how does your request get access when we didn't use Express in localhost? Yes, when you don't use Express, you use Express for this part, for this subsequent requests. But for this thing, for getting the initial HTML, CSS, and JavaScript, you do not need Express. You do not, yeah, you do not need Express. You just, yeah, you don't need Express. You can have this thing running, this server running at some other place. And this is what is done by GitHub pages and by Vercel. Vercel and GitHub pages give you services which can send these HTML, CSS, and JavaScript files which you have written to anyone in the world when they look up your IP address. But then when the client has your these three things, HTML, CSS, and JavaScript, if you want more data for the front end to get after your these three files are with the client, if you want more interactivity, a database and a server, for that you have to set up this other server to which your JavaScript which you have written will be sending requests to, and for this you use Express. And this part, sending your initial HTML, CSS, and JavaScript, is handled by GitHub pages or Vercel. And I hope that was like kind of clear in some way. Hello, hello. And you don't actually need to use Express. You could create a HTTP server in Node.js, but it is a little bit complex since you use Express or other frameworks to, like, as an abstraction. Like, you use Python because you don't want to use C or C++. Samam, but I am asking how does it, wait, did you like actually wanted to write Samam? Shit, that is the name of the person. Shit, my bad. But I am asking how does it route to different pages and get data without using any server in localhost. Okay, so React router. Now you are asking about React router. It is just an illusion. There are no pages. It is just acting as if there are pages. And those pages are just here. The initial HTML, CSS, and JavaScript, which the client got, all the details which you see on those other pages, like page 1 or page 2, it is already here in the initial HTML, CSS, and JavaScript, which was sent to the server. And React is just written in a way which makes it, yeah, this is just an illusion. There, you are not sending any new requests. It is already there. You are just changing the way that they are presented to the client. So I think that is nice. That would make sense. Charles Bukowski, that's pretty good. Are you asking that if we just create a React router, then how would it get different routes? That is just an illusion. Nothing exists. Like, 3 blue, 1 brown, 4, 6, H1, 4, 6 or B. Your DP says something else. I am 762 rated on CF, so anything that I can do that can drastically make a difference in solving questions. Solve questions. That is the only thing you can do. Like literally, just keep solving questions. That is the only thing. No, they do not. So yes, uh, yeah, React router just makes an illusion as if you are sending new requests, but you are not actually routing every data. All the data is already with the client. And for Express, the requests that you are sending for Express, they are actually going to a server which is running somewhere. So yeah, that is it. I know only basic, but I am hesitating when it comes to advanced program. The only thing you can do is actually go and write the advanced program. Yeah, there is no other hack or something. Just go and build your own code forces, code graphs. This thing, pick any project which you think is like you are not comfortable with and go with that. Project was a delusion. The real work is done by the backend. Yes, if you have written, and yes, there are two backends. One backend, there are two backends. One backend is this one, which is sending the initial HTML, CSS, and JavaScript, and the second backend is the one to which you are sending requests. And this thing is free. You can use GitHub Pages or Vercel to deploy your HTML, CSS, and JavaScript. But if you want this thing, the other backend to which your code will be sending new requests, for this you have to like rent some AWS or something. Yo, let's go. And back to this. Shit, my bad. Cool. We can do this. And n will take in all the numbers. Take in n and that is shit. N, x, and y. X and y. X, y. And okay, depending on what these things are, like even or odd. So if n is odd, let's first make the answer vector e size n. Cool. And we can say everything is equal to 0. Yeah, everything is equal to 0. And the first number is also equal to 0, right? Um, yeah, the first number is also equal to 0. So every index that is, then okay, we will start a loop for entire equal 0, I less than, and this is odd. So we won't go to the last number, n minus 1, I plus plus. So if I is also odd, then we say ai equals 1. I, else for int I equals 0, I less than n, we will go to the last number and we will say, yeah, the same thing that we said there, should be the exact same thing. Here we just have one more step, which is a n minus 1 equals 2. So we don't actually have to do this. And we can remove this. And here, if n is odd, then this, yeah. Cool. Okay, so we have our A vector ready. Now, if x is not equal to y, what does that even mean? And yes, um, after taking x and y, we will subtract 1 from them because they are 1 indexed and our array A is 0 indexed. So if A x equals A y, only then do we have to do something. And if n is odd, then we have to do something. And else, if n is not odd, then we can say we'll say x plus plus. Does not matter. We can just increase one of them. Yeah. But if n is odd, if n is odd and either x, either one of them is equal to 0 or n minus 1. X could be equal to 0 or x equals 0 or not x or not y or x equals n minus 1 or y equals n minus 1. If that is the case, then the number which is not in this thing, that is the number which we will increase by 1. So that is the number we will increase by 1. And if x not x not x or x equals n minus 1, then we will increase the y number. So a y plus else a x plus and then we can just output the output I less than n I plus plus and see out a I and then space or new line depending on I equals n minus 1. This is wrong. Wait, no, this might not be wrong. We said here 0 and we can give any output, right? For each output, if there are multiple solutions, print any of them. It can be proven that the always exists. Yeah, it does exist. So for the first one, this is what we said. And shit, this thing does not make a lot of sense. This one, third one. This thing does not make a lot of sense. Here we have 0, then 1, 1, 1, 0, 0, and who are friends. This is the third one. In third, we have 3 and fifth as friends, which means the 3 and these two are friends with each other. Okay, so this makes sense. And this is 6. Why is this thing not 1? This thing should be 1. The index here is 5. This thing should be 1. Why is this not equal to 1? Because of this. Okay, now it is 1. Okay, cool. And I think everything is okay. Everything should be okay now. Here, let's just check. Yeah, now this number is 1, which means this is 1, and everything checks out. This is a friend of this and this, and 1. That is why max is 1. And this is a friend of this, and this. All of them are 1. So this value is 0. And this is a friend of 1 and 0. So max. Shit. When both the numbers are equal to 0, we cannot just increase them because one of their neighbors is equal to 1. And if that neighbor is equal to 1, you cannot do this. Okay. But what we can do is make that number equal to 2. Can we make the number equal to 2? Well, one of them is 0, and we do know that its neighbor is also going to be 1. Then we can make this number equal to 2. And if we, let's say, 1 is the number which is friends, then also it will become 2. So, okay. Okay, then instead of this, we will say 2. And here also, instead of this, we will say 2. And here also, we will say 2. This is the 1 base, and this is the other base. Yeah, makes sense. This should work. Right, now 2. Yeah, I think all of them are correct, even though they don't say that this is correct. This is correct. Let's check the first one. Shit. Here we have, I think this is also wrong. This might also be wrong. We have five numbers. So, and they are 0, 1, 2, 1, 2. And which are the ones which are friends? 1 and 3 are friends with each other. 1 and 3, these two are friends with each other. Okay, this is correct. This is correct. This is correct. We can submit because this is correct because yeah, this is the only extra link, and here this value is the mix of this, and this. Yeah, 0, correct. And for this, 1 is the mix of 0 and 2, correct. And 2 is the mix of 1 and 0, which is correct. And this one is the mix. Ah, shit. This one should be 0. Shit. Okay. Yes, this one should be 0. And if this one was equal to 0, so the only problem we have is when we are changing the numbers. The only problem we have is when n is odd, and the numbers that we are changing are like in close proximity to this tool. Like either one of them is here or here. So what will be the like actual answer for this? 0, 1, 2 is correct. Then this thing is friends with this and this. So if we say 1 here and 0 here, it works out. Yeah, it works out. If we say 1 and 0 here, this thing works out. Yes. So we will say which number we will see which number we are changing. And if, yeah, we will see which number we are, we are, shit, what if this 2 is a friend with some number? That is also one thing. Shit, if this 2 is also a friend with some number, that would be crazy. Hello. Okay, yes, so this is the only, you could say, circle of influence. The numbers, the special numbers would be 0, 1. These are the indices, n minus 1 and n minus 2 and n minus 3. These are the only special cases that you will have to take care of if n is odd. Okay, if n is odd and the number which we are changing is in this range, is in this range. Okay, the phone is going to die and my laptop is also going to die somehow. Shit, it is charging now. I think the phone can hold up for some time. It's 0, 1, and n minus 1. These are the only special. Key. Which MacBook do you use? M1. And what do you think about drawing pads which are connected to the laptop? Well, they are nice, but they cost some money, like which I don't have right now. Maybe after. Mm, these are the only edge cases which we have to take care of. Okay, and how? For real, for real. Money is okay. And then I would say I don't have half email in that case. If this is if we are taking this statement at face value. Mm, 0, 1, n minus 1, n minus 2, and n minus 3. If the number, okay, we can just check. The number that we are changing is this, y. And what would be, and can we change this? Okay, I'm thinking more. Greater than n minus 1, greater than or equal to n minus 2. and check x and y. If if x and y are equal to each other and they are already not neighbors, which would be, let's make, if x is greater than y, swap x and y, so that x is always greater. X is always greater, right? So if we do x minus y, the smallest value of y and the biggest value of y are n minus 1. So if this thing, x minus y equals 1, we are like immediate neighbors, or it is like wrapping around, which would be xy equal to this, or x minus y equals n minus y. This would be the case when we have the last element and the first element as this, as the neighbors. We are looking for when this thing is not true. This thing is not true and this thing is not true. Right, right. So these are not neighbors and their values are like, shit, if they are neighbors, their values will be different. So we don't have to check for this. If these numbers are neighbors, then their values will be different. My bad. Then their values will be different. Yes, no two neighbors have the same value initially. If you have 5 minutes to spare, please explain me four forces. Like I cannot understand how will my rating increase. There are no there is a division 4 contest, and I guess tomorrow or the day after that you are allowed to take part in div 2 contest as well. Yes, my rating is 200. Noob, brother, noob. Just one need 1900. Yeah. So your aim should be to learn things and not rating. Yes, you will gradually realize that. You let rating automatically. Dude, I haven't even started code forcing. Code forcing, yes, that is a verb. I don't know how it works. Then you ask me about the rating. Okay, how does your rating goes up and down? It depends, and yes, I got distracted. It depends on your performance. Like for example, I gave this contest. Let's say, not let's say, I did give this contest, and this contest was lasted. Uh, yeah, for 3 hours, and this was on 3rd of October, and there were these problems. This is the easiest one, then a bit harder, then a bit harder, and I did these problems and standings. I go to standings and friends standings. These are my friends. I was able to solve the first question in 8 minutes after the contest began, and 36 minutes after the contest began. I did the B problem and C after 1 hour and 55 minutes from the time that the contest began. And judging on how much time it took me to solve these questions and how many questions I solved, I had this much score. And depending on my score, I got a standing, like a rank. And according to this rank, my rating went up or down or something by 20 points. And this dude's rating went up by 72 points. So it's kind of crazy. Yeah, that is how the rating changes depending on your position. 20, 30 problems, take part in some contests. Yes, do not redeem it. Gianni and tourists are your friends from my side. Like, this is one-way relationship. These are my friends from my side. They are not my friend. They are my friends, but I am not their friend. Yeah, I can make them my friend just by clicking here. And now Jiangli is not my friend, and now he is my friend, or she, or maybe this is Jiangli's wife. I don't know. Yeah, that is how things are. And also, mm, this is the score that you would get if you solve this question. And back to this. If I so this is like the initial score for this problem A, 500, and this person, Mr. Jiang Li, was able to solve this in 1 minute. So from out of these 5 minutes, he lost one. Out of these 500 points, he lost one. And for 1500, he did this in 10 minutes and he lost 40. And this kind of depends how much. So this is the maximum thing that you could get, and depending on how late you submit in the solution, you get a score that is lower than this number. And at the end, the total is here, and depending on that, your rating is your standing is decided. Yes, Greenland. Yes, there we go. And 23 is the prime number. Yeah, that is how things go. And this was the contest in which Mr. Dominator 69 became a LGM, Legendary Grandmaster. That is pretty cool. Bluff. Drew said it, bluff. It is bluff. Hello. And smart. Okay. So, okay, when the current numbers are not equal to each other, so the number which we are changing, that number could be this or this. Okay. And if it is this, the number that we are changing, if it is 1, can we make it equal to 2? And yes, this number is 1. So this and this are going to be friends. 1, it has a 0, and it has a 1 here. 0, 1, 0, 1, 1. So this should become, yeah, I messed this up. Initially, the things we had were 0, 1, 0, 1, and 2. And now we are saying this is the number that we are changing, and these two are friends with each other. So yes, we can make this 2. That works. Right, that works. We can make this 2. But if this is the number that we are changing and these two are friends, then making this equal to, shit, I made this equal to 2. Yeah, that works out. It works out. This would still be equal to 0. Yeah, works out. And if we made, so what is the possible value for this number? We have 1 here, and we want to change this number. And yes, we must change this number because otherwise we would have to do different things. Maybe we could change this number to 1 and make this 0. Shit. That also works out. Shit. Okay. That works out. Okay. 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 So the only change that you have to do is if x equal, if not x, if not x, then something else. If not x, x is the first number. So we will do a x equals 1, 1, and shall we cannot do this? Cannot do this. No, ax can be equal to 2. 2, yes. Shit, yeah. ax equals 2 and a n minus 1 equals 0. Yes, and we'll do the same thing here. If not y, then a y equals 2 and a n minus 1 equals 0. 2 1 0 1 0. That is what we have as the final thing. 2 1 0 1 0. And who are friends with each other? In the first one, 1 and 3 are friends with each other. This number and the first number and the third number, these two are friends with each other. And let's check. For this number has to be the max of this, and this, which is 2. Correct. This number has to be the max of this and this. 1. Correct. This number has to be the max of this, and this. Correct. 0. This number has to be the max of this and this. Correct. 1. This number has to be the max of this and this. 0. Correct. Okay, this works out. This checks out. This checks out. Let's see. Why? JK, don't get offended. Okay, I think that is okay. It's a bit cool. This took 47 minutes because it was like 21 minutes and then I, by mistake, reset the counter. This was a good question. This was a good question. And why did this took 47 minutes? Because first of all, I was yapping. And second would be because why so much time? Second would be because I was not thinking of what are the invariances which must maintain themselves. That is why they are called invariances. Shit, I was not thinking more logically. Concentration. Yeah, concentration. Yeah, I didn't decide beforehand by applying concentration what were the invariances which will stay, which must stay. And what are the invariances? Invariances are that like just the mix property. When I initially make, when here we initially make the A vector, we know that every number that is here is the mix of its neighbors. That was the invariance. And then we had to see which numbers were like friends. Like there was this thing that randomly two numbers are just friends with each other. Then in some cases we had to change one of the numbers and we had to change it in such a way so that we are not breaking up the invariance. Yeah, shit. And the invariance being that this number is a mix of its all of its friends. First of all, its friends are its neighbors and this new random number that it is connected to. And there is only one random link in the whole thing. So yeah, I was not thinking in terms of invariance. And now I would like to delete it and write it. We have three numbers n, x, and y. N is the total number of numbers we have. X and y are the two random numbers which are friends with each other unconditionally. They just know each other. And since x and y are one indexed, we will minus one from each. And now we will make our answer array, answer vector of integers e and size will be n. And for int I equals 0, I less than n, I plus plus, and if I is odd, then we will say AI equals 1. That is how we are doing things. And if n was odd, then we will say that an minus 1 is 2. So NA is ready. Our initial thing is ready. Now we have to consider this link. And how did we reach this crazy conclusion that this should be the A? We did some trial and error and figured out. If we take the first element as 0, then we can make the next ones 1, then the next one would be 0, then the next one would be 1 and 0. So alternatingly, and if the total number of elements are even, then the last number that ends up here is 1, which is cool. But if the total number of elements is odd, then the last number which comes here would be 0. It would be 0. And we won't be able to have a 0 here and a 1 here, which give a mix of 0. So we change, we check if n is odd. If n is odd, then we change the last number to be equal to 2. So our initial A is ready. Now we check if A x equals AY. Those are the only cases. And how did we reach this conclusion that we only have to make changes if AX is not equal to AY? That is just some trial and error by thinking and thinking. Is Sony something and the numbers are not Jiangli and Raghav? They know each other. Yes, we know each other. Shit. By the way, things going to install Arch on VM tonight. Okay, I can install Arch. Okay. So what we do know is we will have to use virtualization first of all, and we can use CPU accelerator, which is frame hypervisor framework given to us by macOS, and QEMU works fabulously with the CPU accelerator. So we can get native performance from the CPU. But if we want to display things, right, for that we need GPU. And for GPU, Apple does not provide any accelerator. So, and QEMU will have to like do some emulation to provide GPU services, and we will not have native GPU performance, which will make the animation slow, which is this GUI and everything. But Parallels desktop is able to provide native GPU performance. How is that possible? That is possible because Parallels and desktop is may written too much specifically for M1 chips, and it uses Metal API to communicate with the GPU directly. So yeah, but QEMU does not use Metal API to communicate with the Mac Silicon GPU. So yeah, we won't get native performance on the GPU, but we can get native performance on CPU, which is cool. But still, we will, and also since we do not have binaries for ARM binaries for Hyperland, what we will have to do, and I think you can pretty much help me on this. What you will have to do is you will build Hyperland from source. Can you do that? What is the keyboard you use? Just normal Quantron keyboard, supposed to be mechanical. The final statement is this. Yes, the main motive for would be to build Hyperland from source. And if we can do that, I will be very happy. Yeah, let's see. I think you will be able to help in building Hyperland from scratch, from not from scratch, from source. Like on Arch, we can get, or since I'm using Debian, we can get Git, and then we can go to WM Hyperland, and we will git clone Hyperland, and we will have to build it this from source. We will download the code and we will have to build this from from source, like we did with NewVim at one point. Shit, there was a thing written. Yeah, we will have to build this from source, and yeah, that is what we will have to do. There were dependencies. I was trying to build this on my own, but it didn't work out. Mason, CMake, GSL, Nix, OS. I mean, all things come in raw format and you need to make it workable. Okay, and okay, so you get binaries when we do Pacman install or SY something. We get binaries, but there are binaries for Hyperland are not available on apt-get store and also on Pacman store. Binaries for Hyperland are not available in ARM version, right? So we will have to get the source code and then build the source code to get the binary so that we can at least run Hyperland before even configuring it. Screw Linux. Shit. Hmm. No, we will have to do Linux. There is a article about building things. Live for speed. Read online. Stable LFS. Yes. Prerequisites as oh no. Shit, it was I guess in the prerequisites. It's this thing how to build. These two articles are there which tell us how to build things from scratch from source. I think I might, yeah, if I can, I will read this before we get into the discussion. Don't buy a new PC, make it Linux. Yeah, it would be very easy if the architecture was x86, but it is not. Shit, bro is flexing. Bro is actually flexing. I'm 22 in chess. Shit, 2200 is crazy. Shit, 2200 is actually crazy. I have a friend, not a direct friend, but a friend of a friend who is 22. This guy, uh, 2200. Yeah, he's pretty cool. Like, he was playing just 1 hour ago. He's also 22. 22 is like actually crazy. And I have kinesis. Shit. Flexing competition going on there right now. And shit, I am yapping too much. Yes, if these two are same, and why do we have to make the change only when these two are same? We have to figure that out, not using Hyperland, but using some trial and error. And if these two are equal, we need to see if these two are equal and either not x or not or x equals n minus 2, yeah, or not y or y equals n minus 2. If that then something else, we can just choose any random number ax, make it equal to 2. Yeah, that will work. But if this is the case, then we'll see if not x or x equals n minus 2, and if we have if x equal if not x, if x is at the first element, then we will have to make ax equals 2 and a n minus 1 equals 1. Yes, 1. Else a y equals 2, and else if not y, then a y equals 2 and a n minus 1 equals 1. Else if that is not the case, a x equals 2. And again, a is ready for n I less than n I plus plus. We'll say C out a n, a space or a new line depending on I equals n minus 1. This will say wrong because their format is different from our format. But yeah, this is wrong. This was supposed to be 2 1 0 1 0. There are 5 numbers. Shit. So- Okay, so we messed up somewhere. If one of them is at a boundary place, then okay, then we'll see. Okay, here x is at one of the boundary places. No, we just have to check. Okay, okay, okay. X is at one of the boundary places. X is 0, 1. We'll make x equal to 2. And the first number will become 0. Shit, yes. The first number, this number will become 0. Yes, shit. And this is 2 and 0 will be. Okay, we can submit this. Should be correct. This should be correct. Let's see. And we have not done a lot of questions today. Okay, I will now. Thanks for teaching me code forces. You're welcome. I am new, didn't know you play chess too. Hello, yes, chess. I'm bad at chess. How long does it take to get good at competent? 3 to 4 months. Being someone who just learned programming, well, 5 to 6 months, not a lot of time. It just depends on how much you are doing deliberate practice, right? So that you don't get a wrong answer after getting right answer. The order should be opposite. First you should get wrong and then right, not right and then wrong. 0 1 2. Shit. And shit. Shit, yes. If n is odd and all of this. Okay. This should work now. And also there is a very Tyson video which you can watch with me. I'll show you in a minute. Okay. It is running on test 2 if it works on test 2, except 2. Okay. And there is a very Tyson video on being an expert. Very Tyson expert. Yes. This video, you can watch this video and this is pretty cool. He tells like four things: repeated practice, yes, repeated experience, timely feedback, timely feedback, deliberate practice, and variety. Yeah, he tells four things which you can use for becoming really good at something.
Do you
Yep, this video. Watch this. That is very nice. And now on to the next question. We have only done, I guess, two questions today, which is very bad. And before moving on, I would like to go to the washroom and I will be right back in a minute. No. And we'll do more questions, at least one more. And if there was one suggestion for a question, someone said there was a question which connected to laptop. So she said, I should have written it down somewhere. Beautiful sequence was the question. Beautiful sequence, this one. Okay, we'll do this one now. Let's go. Okay, let's call an integer sequence beautiful if the following conditions hold. If length is at least 3 for every element except the first one, there is an element to the left less than it. Okay, okay. For every element except the last, there is an element to the right larger than it. Okay, so yes, this is beautiful. This is beautiful. Length has to be at least 3. Okay. Recall that a sequence, that a sequence is a that a subsequence is can be obtained by removing elements from the start and from the end. We're given an integer array A. Every element is from 0 to 3. Okay, those are the only values. Our task is to calculate number of beautiful subsequences of A. Since the answer might be large, print it modulo this. Number of beautiful subsequences. And all the numbers are this 0, 1, and 1, 2, and 3 are the only values which are here. Here, so all of the sequences, okay, all of the sequences whose length is at least 3. Right, larger than it. So in our sequence, we cannot have two threes and we cannot have two ones. And if there is a 2, then there has to be a 1 to the left and a 3 to the right. So, shit, 3 is the exact number we can have. There are, wait, subsequence or subsequence? Okay. Answer here is 1. Here is 0. Makes sense. And here, okay. So how many subsequences of 1 to 3 can we have? That would be the answer. Okay. So for this one, how many 2's do we have to the right? And for each 2, how many 3's do we have on the right? So for this one, if we go with this 2, let's say it's this, let's think about for 2. If we do choose this 2, this 2 has 1, 2, 3, 3 threes to the right. So yeah, let's say this 2's value is 3, or we can write this here, right? So okay, this 2's value we are saying is 3, and then there is this 2, and its value would be 2. Just how many number of 3's are there to the right of it? And for this 1, for this 1, right? Yeah, cool. And now let's say for 1, for this one, if we go with this 2, there are 3 possibilities. If we go with this 2, then there are 2 possibilities. If we go with this 2, there is 1 possibility. If we go with this 2, there is 1 possibility. So the sum of this thing, if you go with this one, then there are in total 3, 2, 1, 1, 5, 6, 7 possibilities. And if you go with this one, then there would be plus 4 possibilities, which is wrong. Answer is 22. 22. Answer is 22. Answer is 22. 1, 2, 3. Said, but we can have a number of twos in the middle. Shit, yes, when we have this two, we can have in the middle this, or this two. There are 3 possibilities. Shit, okay. Shit, this is more complex than I thought. Okay. We can have a 1, then a bunch of twos, and then a 3. A question from like you do AOJ or ACD, or just filter on CF. Code forces. What is ECD and what is A2OJ? How to learn English in 2025? Watch anime, and yes, if you want to learn English, then there are like 4 things you have to do: read, write, speak, and listen. And for reading, you can read books. For reading, you can read books. For writing, just take a pen and paper. For speaking, you can go to a website called uh, freefortalk.com. You can go here and you can start talking to people. Just join random channels and start talking to people. Freefortalk.com. Yeah. And for listening, there are like podcast or anime, anything, whatever works. Hello, bro is back. Can you share the question, people? Where can I read the question? Yes, you are. This is the question. Beautiful sequence. Bro, okay. Bro's getting too much into the lore. Rating currently, my rating right now is 1420. In which year you are and in which domain? CSES, AIML, 5th semester. Yeah. just that. And okay, I will do this question first. 1, 2, 3. Okay. So we can have this. So we will see which speak. There is a question. I've done a question like this. Shit, makes so much sense. Ah, shit. Okay, okay, okay. Yes, yes. I was doing the same mistake that I was doing the first time I was solving a question which was similar to this one, and someone from the chat said that you are stupid. This is the right way. And yes, I said, yes, you are correct. I agree. So, okay, instead of saying which one I'm going to choose, I will say which two I'm going to choose. Right. Let's say if I choose this two, then how many twos can I go with on the left, and how many twos can I go with on the right? And I would need two things. Prefix of I, where if I give in the index of I will have the number of ones. I will have the number of twos in the range 0 to 1, 0 to I, where 0 is included and I is not included. Right, that would be the prefix. And for the numbers, and I need another thing, we can call it like suffix or something. Suffix I. This is not a very good handwriting. Okay, let's do this. Vector A size n for in reference F on A. See in X, A is now filled, and we need two prefixes. A prefix size n plus 1 and another, let's call it suffix size n plus 1. And how are we going to define these? We say prefix I would be count of twos in the range 0 to I, where I is not included. Count of twos in this range. Count of twos in this range. Count of twos in this. But not just that, we have to see which one we are going to choose. Which one we are going to choose. And according to that, we'll have to see how many number of twos there are in the middle, right? That is what we need, which we can easily kind of find out using this prefix. Okay, so okay, when I am when we are at a two, let's say there is a 1, 2, 1, 2. Yeah, those are the things. And with this two on the left, we let's say there are L number of possibilities, and on the right, the number of possibilities for choosing something is R. Then the final answer for this two is going to be L into R, and we will be calculating things multiple number of times. Shit, no. We just take down the index of all the times that there are ones in the thing, and all the times that there are threes in the things, and we will pair up each one of these with each one of the times that there are threes, and the number of possibilities would be let's say the number of twos in the middle. Let's going back to the main example here. We have a one here, we have a one here. So we have one, two ones, and we have three threes, right? And the total answer would be, if you go with this one and this three, let's say X is the number of twos there are in any one and three pair, then the possibilities for this chosen pair of one and three would be X minus 1, X minus 1 power 2, X minus 1 power 2, or more correctly, X power 2 minus 1, X power 2 minus 1. Okay, so between this one and this 3, there is only 1, 2, and let's say this one and this. So answer for this pairing is 1. And then answer for this pairing, when we are going with this one, and this 3, there are 2 2's. So 2 power 2, 4, 3. There are 3 possibilities for this choice. And for this choice, when we are going with this one and with this 3, there are 1, 2, 3, 4 possibilities, or 4 twos, then 16 minus 1, 15 possibilities in total for this. And when we choose this one and this, okay, we cannot choose this 3 with this one because it is to the left. So we'll choose this one and this 3, and there are no 2's in the middle. So 0, 0 power 2 minus 1 is 0. So 0 for this. And then for this, we are choosing this one and this 2. There are 2 2's. So 2 power 2, 4 minus 1 minus 1, that would be 3. So 3, and total answer should be 3 plus 3 plus 15 plus 1, which is 20, which is 22, which is the actual answer, 22. Let's go. We just have to figure out a way to calculate this. Which college? AKTU? AKTU? Yes, AKTU University. Okay, now we have to just calculate, find a way to calculate the answer. We know what we have to calculate. Two pointers. This is what we have, and should we cannot pair up everyone with every three because the time complexity can be too big. The time complexity can be too big. Or maybe let's see if there is a closed formula for this. That is, in which we don't have to iterate through everything. We can just put in some values and we can figure out the answer using those values. So for this one, we know we will pair it up with these three threes. And the only thing that we need from this would be the number of twos. Here for this 3, the number of, let's write for each 3, the number of, for each index, the number of twos which are to the left of this index. So here are 0 twos to the left of this one, to the left of this 2, there is 0, there are 0 twos. For this 3, there is 1 2 on the left. For this 2, there is 1 2 on the left, which is this one. For this one, there are 2 twos on the left, this one and this one. 2 for this 3, 2 for this, 2 for this 3, and then for this 4. Okay. And when we are at a particular one, can we figure out the answer? For this one, we clear saw that the answer was, let's recalculate, the answer would be 1 plus 3 plus 15. Can we figure this out directly? Let's say we will keep track of this value, and this value. That is the values at every position. We have a 3. Okay, if we have that, then what do we do? Then, shit. Then in our final answer, we have 1, 2, and 4. Let's just keep track of these values. And then when we move on to the next one, which is here, we'll see 2 and 4, but these are not the values. The values would be 0 and 2, which is this value minus the value of the current one, 0 and to figure that out, we had to go to each of the threes which are to the right of this number. To each of the threes, let's say we initially we will have this number. Initially we will have this number. Yes. And yeah, okay, let's say we initially will have this list, and we will start moving from the first index, and whenever we see a 2, we will also have a counter which would initially be equal to 0, and whenever we see a 2, we will increase the counter. Yeah, it will we will increase the counter. We will increase the counter. No, 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 no. That will also not work. That won't work. Hello. I think it's just 3 sequences. 1 Fibonacci, 2, I don't know. 3 is constant. 3, or I don't know. Shit. John Edward from Ecuador. I don't know. It is just 3 sequence. 1 Fibonacci, 2 is I don't know. 3 is constant, or I don't know. Yes, 1 and 3, you will have always one number of 1, and at the end you will have, should, the video is inverted. So at the start you will have 1 1, and at the end you will have 1 3, and you have to calculate how many number of 2s there could be in the middle, and at least 1 2 should be there. So if there are like x a number of 2s, then each 2 could be there, could not be there, or could be there. So in total there are 2 power x possibilities, but we don't want the possibility when we are not choosing any 2. That is when we are not choosing any 2, so we subtract 1 from this, so that there is at least 1 2 always. Hello. Yes, you can start. Does not. Yeah, that is pretty good. Then see, should I start with striver DSA right away? Yeah. Is there some particular reason why you have to wait? You can just start, and all the best. You can just start. There is no reason you should wait. And hello, PC, Karan Kasan PC, Hassan PC. Hello. Shit, I mispronounced it like 3 times. Kamar Hassan PC. Hello. Okay. So figuring this out, what I don't want to do is iterate for each one through all the threes that are to the right. But I think, can we do it? Or we will only iterate through the ones which have higher which are to the right of this current one, and there is at least 1, 2 in the middle. Now, would that be like sufficient? What if we have a bunch of ones, then a single two, and then a bunch of threes, like a lot of threes? And let's say these are n by 2 and almost n by 2 number of ones and twos. And in this case, the total time complexity would be n by 2 into n by 2 whole square, n by 2 into n by 2, which is not very good. Yeah, this is not very good. Or instead of this, we can group them in a map. We can group them in a map and we will see how many threes have one number of ones to the left, one count of twos to the left, and how many threes have two twice a two to the left, and how many threes have three. And if that is what we do, then here in this case, the time we will only have, we will say that there is the number of trees which have a 1 is just this much, n by 2. So we will be handling all of these trees in one go. So that is nice. That is nice. I think we can implement that, and that would also be okay. But what if there are twos scattered? If we have a sequence like 111, which are like n by 2 number of ones, and then we have a 2, then 3, then 2, then 3, then 2, then 3, then each of these threes will have their own value in a key map pair, and at max this would be n by 4, and still the time complexity is pretty high, n by 2 into n by 4 into n by 4, and n can be at maximum 10 by 5, so 10 by 5, 10 by 10 divided by 8, not very good. Yeah, this is still bad. Hello, yes, your best course for AIML. I wouldn't know. I'm not into AIML, but yes, shit, yes. Not a course, but I would say a nice person. Andre Karpati. You can watch his videos. Andre Karpati. He's a pretty cool guy. And hello, what is the difference between lead code and code forces? I would, well, lead code is more the type of problems that you are solving. They both require algorithms and data structure knowledge. But I would say that the mindset in code forces is very witty, right? You have to be very quick on your feet to come up with a solution, as in, because in code forces, the amount of time in which you are solving a question, it does matter. So in code forces, you have to be very quick, fluid, lucid intelligence. And on lead code, when you see a question, you can just take up however time you want. It doesn't really matter. But I guess there are also contests on lead code. So yeah, shit, JD Vance, Linux Lunar and JD Vance right there. JD Vance meme. Shit, okay. Whatever we have to do in this one, like we know exactly what we want, but we just don't know how we can find it and what is that we want. We have a bunch of ones, twos, and threes scattered throughout. and we have to pair up everyone with every 3 and get the number of 2's in the middle. That is what we want. There has to be a faster way to do this than just literally pairing up everything with everyone. When we are at a particular one, can we in log time, logarithmic time, or in I think we have I think I have this. If we have this, let's say we will initially have a number, mm, let's say some number, and that number would be equal to, we will see how many twos are there in between the first time that we see a 1 and the last time that we see a 3. So here there are 4 twos in the in between the first one and the last 3. So this res would be equal to how many? Okay, this number will be very big. This number will be very big, and then we will also be subtracting numbers. Okay, let's say res would be equal to this count to power this count minus 1. Okay, right. And then we will go to the next one. And while we were going to the next one, C was the original count. Now we encountered in the way two twos and one three. And what does that tell us? Shit, that does not tell us anything. Shit. Yeah, we will have to do something else. Yes. We just know that C initially was equal to 4. Now C would be equal to 2 because we C is the number of twos that we have on the right, and currently we are here. There are only two twos. So uh, I think, yeah, we require something different. The laptop is going to die. Like, actually, not even kidding. Saved by the bell. Okay, shit. Yeah, and this is fine. This is fine. This is fine. This is fine. I would say I have been streaming for 3 hours and 44 minutes, and now I think I can, yeah, because I do not want to read the editorial right now, and I would like to do this question on my own without reading the editorial. So I will do this question tomorrow, and that would be nice. And yeah, just a little break. Yeah, so this would be it for today's stream. We did 3 questions. My bad. We did 2 questions in 3 hours and 44 minutes, which is absolutely horrendous. So that is actually a fall off. Yeah, that is bad. But yes, this is the end of today's stream. And why am I not doing this question right now? Because I think it is better to wait and then try to do this question on my own rather than looking at the editorial right now, because yeah, I've been exhausted a little bit. Yes. Yeah. So that would be end of today's stream. That would be the end of today's stream. And Thank you for being here. Bye.